Good afternoon, and thank you all for joining us. Today's webinar, Lowering Scrap Rates from the Processor's Point of View, is brought to you today by Paulson Training Programs and presented by DynaPurge. Your presenter today is Scott Paulson. Scott Paulson is the Vice President of Development for Paulson Training. He joined the company in 1995 and is part of the team that has developed the world-class training products and services Paulson Training is known for. Scott has a bachelor's degree from Central Connecticut State University. He has presented at numerous Antech conferences, SPE chapter meetings, and other major industry events like MPE. As VP of Development for Paulson Training, Scott is responsible for the direct quality and production of Paulson's entire product line, including its new injection molding simulation software, SimTech, and Skill Builder. My name is Trey McDonald with you all, and I'll be moderating today's event. Please send us your questions by typing them in the question box located on your screen. Our panelists will answer them at the end of the presentation. We are recording today's event and will send you a link by email when the slides have been posted to ulprospector.com. Now at this time, I'd like to turn the presentation over to Scott. Scott?
Thank you, Trey. Good afternoon or morning as the case may be to you all. Thank you for joining us today. As Trey mentioned, feel free to use the question box on your interface there to ask any questions of us and the panel here. So with that, let's get going. Just quickly, I just want to outline what we're going to cover today. We're not going to take too much of your time. I know how busy we all are. But thank you to Prospector, UL Prospector, and DynaPurge as well for the opportunity to give this brief discussion. If any of you haven't used the DynaPurge product line, please consider it. Great product, great company. So before we begin here, just a little bit about Paulson Training. Actually, Trey, we just did a quick poll question here of I'd like to know how many people have heard of us, if any. So we've got a real quick question. Just use your mouse to respond. If we would get that going, that'd be great. So I can better tailor my presentation. So over the next few seconds, take care of that. While we do that, okay, about 3/4 of you or so have heard the name at least, so hopefully that's a positive thing. But what we do is we're in the training business, and we have been for some time in the plastics processing industry. Specifically our niches, and I know you folks come from many different backgrounds, but specifically our niches are injection molding is about 2/3 of our business or so, and then the various extrusion processes such as pipe, profile, sheet, and lately we've gotten into some revised courseware on extrusion blow molding and thermoforming, both thick and thin sheet gauge thermoforming. So we, we're certainly not in every product. We go by market size, but we do have a lot of experience in the industry in general, and have been around a while. 40, what do I have here? Let me do the math. 38 years. Sorry about that. We've trained a lot of folks over the years. Hopefully we have a well-respected, trusted brand, and a lot of companies use our training to improve their operations. The industry has changed a lot over the past few decades that I've been in it anyway. Things have gotten a lot more competitive, as I'm sure all you are aware, and many different new technologies we use. Although my father, Don Paulson, some of you may have heard of, is the founder of this company and an acknowledged injection molding expert. We do a lot of other training as well, so we reach out to the best and brightest in the industry on all of our products to make sure that we have current technologies and are up to speed on things and constant product revisions. So scrap. Scrap is an issue that affects us all. There are many ways to define it. For this one, I've chosen to be pretty broad about it. And it's not just the parts that end up in the grinding bin or in the dumpster or wherever they may end up. It's really any part. It's a part that could have been molded, or for you extrusion guys out there, could have been sent on the line, but wasn't because of product inefficiencies. Machine time that could have been used but wasn't because the machine was down. Basically all the raw material that doesn't end up in a part you can sell to your client, or if you're captive, it's same matter. I consider that scrap. So I'd like to broaden that discussion a little bit just so that we all realize it's just more than that part that gets tossed because of whatever surface, appearance, structural defect it may have at that time. It's really the root between profitability and improfitability. Now, sometimes we can regrind our scrap and sometimes we can't. Depending on the process, obviously, most of the time we can, unless we're in certain industries, as we know, where virgin material is required. When we can, that's good, except that we have to go find that bad part, and they usually don't come in ones. Identify it, grind it, reuse it at a consistent rate, hopefully, and then obviously more important than any of that is to solve the problem to begin with. Now, since we do come from different backgrounds here, different processes, I'm going to keep things pretty high level. I'm not going to talk too much, although I am injection molding inclined. That's my own experience. I realize we don't all do that. So in terms of, what knob to tweak and so on, you're not going to hear any of that because I don't know what process you're involved in. So, I'm just going to keep it on a broader kind of management level, if you will. So many, many different causes of scrap. Obvious one, we have a quoted reject rate on any job we might do, and if those reject rates go higher than anticipated or quoted, that's scrap. We do expect some scrap. I mean, I don't think anybody's making a 100% perfect part. Maybe there is. That would certainly be the goal, but in the real world, we'd still have scrap because of startup times, product waste to get to material waste to get to first good product. These things are inevitable. Cycle time or line speeds for your extrusion guys is another biggie. What's the harm to, no offense to anyone out there, but what's the harm for the shift manager on third shift to say, you know what, life's a lot easier when I increase the cooling time by a second and a half a cycle, the parts come out better. Well, it's not what we quoted, so there is some harm to it perhaps, and I'll show you a little bit more. We have a spreadsheet analysis that we offer on our website that kind of goes into detail on the harm and the cost of things like that. So uptime, downtime could be worse than quoted. This is common. Things break, or even worse, things are broken by, maybe obviously not on purpose, but machinery breaks, dies break, mold break, injector bars break. Things happen during the manufacturing process. The fires happen every day, hopefully not literally, but you folks know that better than I. They happen every day out on the floor. Next to last bullet, excessive time to first inspect product or part. We, particularly, for my background, we change molds frequently, sometimes many per shift. All the time it takes to that first good part, and then repeatability, that's all scrap. That adds up. And then obviously, as I mentioned before, we have some efficiency differences between shifts that are possible. Some of the other causes, and this is, these are the ones off the top of my head. You guys probably come to the webinar today with several instances in the past few weeks about, I never thought we could do that, and it happened. So, maintenance is a big issue. Maintenance gets delayed or postponed or not performed for whatever reason because, hey, things are running good, or we don't have the replacement part, or whatever the case may be. That can hurt you at the end. Raw material availability, not just inventory, but it's suitability. Does it need to be dried? Is it appropriately dried? Is it coming from the outside? Temperature changes, things like that. Plastics material itself is what keeps our lives so interesting. It's a very unique material with its non-Newtonian behavior characteristics. It's a tough one to work with. It's got a lot of qualities that are good. It's also got a lot of qualities that can keep you up at night. So that's a big one. Just simple inventory control. I've seen jobs shut down because they have nowhere to put the parts, because the truck didn't come. So, that's a sad but true. It happens. A lot of reasons why scrap gets generated in a typical plant, and nobody knows those reasons better than you folks at your own particular job. So again, my sort of broader definition here, it isn't just the bad parts you make, it's the parts you don't make at all due to inefficiency. If I can make 1,000 parts an hour and my machine goes down for 10 minutes of that hour, well, to me, that's essentially lost production. That's really the same as scrap. Economically, it's the same as scrap. From the molding perspective, and I'm sure this runs just as true from a extrusion, a continuous process perspective, you don't need to make one good part to make up for one bad part. You need to make 2 or 3 good parts. And that simple fact is because I need to find those parts. That takes resources and manpower and time and money. I need to grind or discard them depending on what my process entails there. And obviously even should have been the first bullet is I need to fix the problem and make good parts. Nobody makes one bad part. When they come in streaks. And particularly you guys in extrusion use a lot more material. A typical equally sized extrusion and injection plant, the extrusion plant's using somewhere 30+% more material just because of the nature of the process. So it adds up. One thing I want to do, let me back up one slide here. Yeah, I want to take you over to what we call here, make sure you can all see this, there we go. And again, my apologies to the extrusion guys out there, but the concept's the same. This little tool here, which is on our website, is a simple application we've developed to show what inefficiencies cost in a given molding job. So on the left here, enter your data below. We've got assumptions that we all make on a given job that has been quoted and accepted and is ready to go to press. Same thing for extrusion. In fact, we're working on one with the parameters of extrusion, so that'll be up soon too. So let's just say, and these are assumptions, and I'm going to mention percentages more than absolute values so we can all relate. But it's a 500-hour job, 500 hours of machine time. Quoted machine hour rate's 48, could be anything. Quoted profits 15%, fairly typical. Quoted cycle times 20 seconds, and here's where we get into the ability to manipulate what happens in the real world and see what happens to our quoted profits. So you can see down in the lower right, we're scheduled to make $3,600 on this job. You could expand these factors by 10, by 100, doesn't matter. The values, percentage-wise and from a business perspective remain the same. So, just for simplicity's sake, let's say on average I can only mold this part at 21 seconds. Or maybe first shift and second shift do it at 19 and third shift does it at 23. At the end of the day it averages 21. So that single second in cycle cost me, you can see these numbers in red on the right, almost a third of my profit. By going that, in percentage-wise, that's 5%. So let's say my line speed was 5% slow over what I quoted, or my cycle time as exampled here, is 5% slower than I quoted. Now my reject rate, right here we're at 1%, 1 out of 100. Well, things didn't work out so good. So the reject rate goes up, I don't know, fair amount. That doesn't seem to cost us much on the surface, just $20 in this case. But these are pretty low reject rates. My assumptions are pretty low here. That could easily become, and this doesn't include the cost, you'll notice, of finding them, grinding them, and reintroducing that material back into the process if you can, or eating the cost if you can't. Now in my experience, I've been in a lot of plants. This uptime, downtime one is a biggie. Things happen. Things break, people don't show up, piece of machinery can't be used, we're waiting for a part for the die, we're out of this, we're out of that, things happen. So instead of being up, 90 minutes out of every 100, you know what, I'm only up 80 on average, 80 minutes out of every 100. Well, that's a huge loss. That's, ballpark 10%, more like 12%. So now, just from that effect alone, I'm down to $2,400. I've lost $2,400 of my quote-unquote profit. Not only that, when you add up all these bad things, I'm really in the hole here. I'm basically breaking even on this job. I'm making $37.94, which is not going to pay for lunch. So these little inefficiencies add up, and that's always how it is. It's rarely one thing. You can really walk out on the floor and say, if it wasn't for just that, my problems would be solved. That's too easy. That's not how it works generally. It's a combination of things over time, over shifts, over personnel. It's a lot of little things added up. But the good news is, these situations can be reversed. Instead of molding at 20 seconds or X line speed, I can mold at 19 for example. I can, I should use one more decimal place here. I'll keep my reject rate the same. And if I've matched or even increased my uptime, I'm supposed to be up 90% of the time, I'm up 93. The guys are doing a great job out there. Well, now I've gone from quoting $3,600 to making $5,600 thereabouts because of that increased efficiency. It's a two-way street. The assumptions haven't changed. Number of hours on the job, machine hour rate, quoted percent, those are fixed. You know, and this is where, particularly folks in management, this is where we're getting the squeeze. Customers never ask to pay more for a given part. They ask to pay less. So that's where, and particularly, you know, it's a global economy. There's competition from everywhere. Although it's great to see a lot of manufacturing come back to the States, we've certainly noticed it. You know, I love to see that. I hope it keeps happening, and it will keep happening. But assumptions don't change. Therefore, what's under our control is what happens on that production floor. Let's go back to the PowerPoint here. So again, just to hit this point that I hit earlier, you know, scrap isn't just the bad parts you make. It's the parts you don't even get a chance to make. And finding and identifying parts costs money and time. So there's a couple ways to reduce scrap. And again, I can't get process specific here. I'm not in your plant and I'm not at your machine. You've got, I'm sure, well-qualified people doing that. But in my experience, here are some of the short-term causes, meaning, you know, days, weeks, maybe a month or two, that take a while to get sorted out. The raw material, can't stress it enough. Typical expense percentage on a production facility, raw materials ballpark a third of the cost of doing business. That's big. That's a lot of money. So that's why scrap is such a harmful, not only is it a lost production hours that you can't get back, but obviously straight up material costs that you can't regain. Second one that happens a lot is machine performance. This includes things like maintenance, whether the machine's calibrated properly, whether it's operating to spec. And I'll be honest, all the time I've spent in plants, new, quote-unquote, new machine versus maybe a little older machine, doesn't matter all that much. I've seen plants where older machines are properly calibrated and tuned up and well-maintained that embarrass plants with newer machines that, you know, aren't as maintained, never been calibrated properly, or more commonly than all, nobody knows how to use them properly and their full capabilities. So I don't, you know, certainly there's capital equipment that will help solve problems. You know, obviously automation is big these days where we can take labor costs out of the equation where appropriate. Nothing wrong with that. But don't spend $1 million on a machine and pay somebody 15 bucks an hour to run it without training them. Third thing that I see a lot is mold and dye issues. They're complicated, they're expensive, you know, particularly on the injection side. Some of these high cavitation molds, you know, you can run into 6 digits on these molds quite easily. And again, people, operator error occurs, you know, screwdrivers prying parts on molds, things happen. And those things can be expensive. And then there's downstream issues, obviously more relevant in extrusion, but what I'm really talking about here is even part handling, quality, inventory. Where do we put these things? Where do we put our parts? Are they cooled appropriately? You can warp a part by putting it on a table the wrong way. So all the parts need to be handled, you know, appropriately, depending on their process. In the longer term, which is, you know, really where business success comes, there are, you know, manufacturing techniques, which is a nice way of saying, do you know what you're doing? Have you identified experts in the field, maybe gotten their, you know, expertise and wisdom and guidance over it? Are there new techniques in the industry that, where it does make sense to spend money on a piece of equipment? Are we working on constant improvement? Do we get input from our staff? People who know best are generally the ones on the floor doing the job. Little things add up. So constant improvement is sort of my mantra out on the floor. You'd be amazed what happens when you talk to the folks on the floor who have been there a while, who you've sorted out and trust. They have good ideas. Listen to them. And the second bullet here is, you know, obviously right up our alley. We're in the people business. So nobody was born with injection molding or extrusion or any other process expertise. We are all made and we are all influenced by the forces around us. Not only our on-the-job experience, which is a good way to learn. It's a fine way to learn, assuming your teacher knows what they're doing and you have the time for it. But, we don't learn how to fly airplanes by going up in an airplane right away. We use simulators and we use, past experience from good instructors, and we do a lot of classroom time and things like that. Not the perfect analogy, but, applicable. We do simulation in our injection molding product line simply because no one says, hey, Scott, go out to machine 12 and just play around for a day. Let me know what you learn. That doesn't happen in the real world. Hence, simulation is a very, very good thing. But, you're never going to get to where you want to be until your people are up to a certain level. It's a major expense in your company. You might as well invest in their future. And as I mentioned, many times production equipment deficiencies are relevant. Not so much the equipment per se. Sometimes your car runs rough. It might need a tune-up. We don't do tune-ups much anymore, but nevertheless, I'm sure a lot of us remember the older days when replacing spark plugs was necessary and things like that. Same with a lot of this production equipment, particularly looking at 10 plus years old. Things need to be calibrated. A lot of these machines run thousands and thousands and thousands of hours. So they obviously need calibration. Maintenance in the long term, a regular maintenance schedule is beneficial. Not crisis maintenance, meaning machine X just broke. We need to get out there and fix it. That's not maintenance. That's just putting out fires. Maintenance is what you do when nothing's gone wrong yet. So those are the things we need to focus on a daily basis. Maybe a little short-term pain, long-term gain. And those, gosh, I could be making parts. Well, 2 days from now, when that vital component fails, you're definitely going to not be making parts for several days. And again, downstream issues, it kind of ties along. Am I doing things efficiently? Is my part traveling the least amount, touched by the least hands possible, or is it getting passed all over the plant for various operations with no rhyme or reason per se? Okay. My mistake, folks. Here we go. So my recommendations, getting near the end here, my recommendations are to benchmark your equipment. And again, I'll use that word calibrate. Your machine, just like a car, came out of the factory with a certain, set of specs that it could maintain. There's no reason that those shouldn't be still good a year or 2 or 3 down the road. Sure, screws don't last forever. They need to be pulled, replaced, cleaned, maintained. Molds don't last forever. That's part of the ball game, and there's no way around it. So, if you want to be in the business, these are things you have to do. Now, your raw material. Everyone loves blaming the raw material supplier, me included, because generally they are not there on the production floor when we're all scratching our cheeks looking at the problem, and they're the big guy. So they are first to blow. No question there are variations in raw material, even in a given batch. That's the nature of plastics. This long skinny molecule that that gives us our living is a tricky one to work with. And even the best compounders and even the best material suppliers are not capable of making a quote-unquote perfect plastic with perfect behavior. It's not going to happen in the past, and it won't happen in the future. And not only that, once it comes to our factory, obviously it needs to be stored, delivered, dried if necessary properly. All these things are relative, and that's what keeps our industry interesting. This next point I think I've mentioned enough. I'm kind of big on maintenance, not crisis maintenance where, oh gosh, machine 14 broke, let's go fix it. And let's see. So, scrap doesn't create itself. People create scrap. Hate to state the obvious here. I think we all know that. So since people are responsible for the problem, if you will, I wouldn't say problem's the right word though, it's for the business reality, then people can help solve that. Every quality, world-class company that I know or that we've worked with does a good job of many of the things I've mentioned. Training their people, maintaining their equipment, staying up on trends, things like that. They all do that. It's the thing they have in common. So your workforce is really the key to reducing and eliminating unnecessary scrap, proper techniques and knowledge. The onus is on management, in my opinion, to identify the problem areas, or even ask what the problem areas are. The job of management is to provide the tools and resources for your employees to do the best job they possibly can. That doesn't matter what your industry is, what you make. That's always been the case in good business. So follow some of the tips and techniques that I've outlined here, and again, apologies for sort of the higher level broad strokes here. If we were all in one single process, we could get a lot more specific, get our hands dirty, if you will, which I love. But for now, this has just been a brief introduction of sort of the nature of the problem, and hopefully you found it a little bit helpful. I think Trey's listening in. If anybody has any questions or thoughts, comments, just feel free to type away in our questions box on your interface there on your screen, and we'd be more than happy to give my 2 cents. Trey?
Perfect, Scott. Thank you so much for that. Yeah, we are going to go ahead and move over to our question and answer session. So you've got a great expert here in Scott. So please do send us your questions. We do have a couple of those. We also did mention that we are going to be sending you guys a link via email with the recorded copy and a copy of the slides. So do be checking for that. And Scott, maybe as we kind of wait for some of these questions to trickle in, do you have maybe what are some of the questions that you receive the most from customers, or maybe when you do go visit and you're taking a look on the floor? So just kind of a top 5 or top 10 sort of questions you guys get a lot.
Sure. Yep. We usually get called. We're kind of like the plumber when the sink's gone bad. We usually get called. When the crisis. Occasionally ahead of time when some enlightened folks, but usually we get called when the crisis is happening. It goes like this: help! My people don't know what they're doing. We're making tons of bad parts, and business isn't going well. To which I say, all perfectly normal and all perfectly fixable. You're not alone. A lot of companies face the same thing. But knowledge is the answer. Knowledge and maintenance, I guess, would be my 2 points that I really couldn't stress enough. I could get specific with molding jobs and so on, but what makes the industry so fascinating, both molding, injection, extrusion side, and other processes as well, is almost the unlimited amount of variables and headaches, if you will, that we can face, on a daily basis. It can really be mind-boggling. But we like to think, and maybe some of you know our slogan, but we teach from the plastics point of view. Fortunately, the plastic does not have the best intellect, and it only knows 4 things: pressure, flow rate, cooling rate, and temperature. So unfortunately, our machines don't have those 4 knobs, but we do have other control adjustments that affect those 4 things. So when you approach a given problem from the plastics point of view, okay, like from the injection side, I got a short shot. To me, that means I don't have enough plastic molecules in the cavity. I know that sounds simplistic, and I know we can say, all right, let's increase injection pressure, for example. Many ways to skin a cat here. But when you think of it from that core point of view, breaking things down to the score point of view, that's what I like to do because, and I do it too, people get wrapped up in their problem. Why is my clear part have splotches in it? It's like, okay, let's take a step back and examine why. It's not, ultimately the solution is generally simpler than you think. Speaking of which, okay, what's the best, here's a question, folks. What's the best way to change from clear PC to acrylic? All right, from clear polycarbonate to acrylic. Well, that's where I'm probably going to recommend that we go to our friends at DynaPurge. It takes just a minuscule amount of one to contaminate a whole bunch of another type of material. And with hang-up, particularly maybe on a little bit of a worn or pitted screw, that bad, if you will, or unwanted material can hang out for a long time, ruining an hour's worth of parts while you scratch your head. Typically you'd want to run, I don't know the viscosity of each of these, but polycarbonate's pretty resistant to flow. You'd want to run the lower viscosity, lower resistance to flow first material, so the second material would have a sort of cleansing effect, if you will, not unlike a purging compound. And if problems were really bad and you had the time, I would literally not go from one material to the next, but in the interim I would run some type of purging compound to thoroughly clean out my inner parts there, so that I don't run with contamination. Sometimes 20 minutes or a half hour of emptying out the barrel is worth an hour of not doing that and getting some type of contamination in your second part or some undesired characteristic. Doesn't have to be visual, it could be structural. All right. What's the best approach to determine the level of scrap to use in production and still maintain repeatability of the process? Excellent question. Scrap, aka regrind, we all use it. Obviously with the cost of material, if we can use it, it is a good idea to use it. As we like to say, it's not bad plastic, it's just different plastic. Misunderstood. So a couple of very, very key factors here is, it needs to be handled in the same way a raw material would. If it's hygroscopic, dry, it may need to be re-dried, although if it's, ground and put right back in the process, probably not so much. But number one factor is consistency of use, meaning the ratio at which it is put in with the virgin. If it's 10%, fine. If it's 50%, that can be fine too. But it can't be 10% one hour and 50% the next hour. You're going to have vastly different part characteristics, or the potential for vastly different part characteristics. Typically, the viscosity of a regrind versus a virgin is going to be slightly different. Depending on the material, it might have more sensitivity to heat degradation. So these are things one needs to be cautious about. It's perfectly moldable. I'm a New England cheapskate kind of guy, so I'm all for using it, and it's perfectly moldable or extrudable, but it does need to be handled consistently. If you want to introduce a 12% blend, keep it at 12%, or on some wholesale material change or a mold change, you can run it at a higher percentage, figure out the process parameters that'll work, but be consistent. You cannot dump a bucket of regrind in on one shift and not do it on the next shift. You're going to create just a whole lot of problems for yourself. Anything else on anybody's mind? Well, did you have anything else at all, Trey?
Looks like we had one more question come in there.
Yep, one more there. Okay. Do you have any outlets for scrap? I do not, per se. I know people in the business, but I'm not sure I have a real good answer for you there, sir. I assume you mean selling what you don't need, or acquiring maybe perhaps somebody else's, but probably the first one. There are certain materials in demand. Recycling is big business these days. Yes, okay. Selling what you don't need or want. Yeah, I don't really deal in that side of the business. Kind of drawing a blank other than standard Google it type answer, which I know is not the toughest answer to come up with, but if there's a market, you'll find the market with a little research. Some of the more commodity materials, that's difficult. If you can't reuse it, perhaps a barter is in order. One suggestion I would make, actually, I wanted to make this point earlier, was that some of you belong to the industry trade associations, the SPE, Society of Plastics Engineers. There's one industry association called MAPP, MAPS, out of Indianapolis, Indiana. We're a member of that. They just had their annual conference. Outstanding industry organization, real advocate for us. They do everything from, lobbying in Washington to, more importantly, dealing with processors' real issues. There's a lot of bartering going on in the material world there. Does anyone have, 2 gaylords of this for a gaylord of that? It's important that we communicate in that way. So if you're not part of those organizations, both SPE and the MAPS organization, I would encourage you to at least investigate that. Okay, when we use DynaPurge, sorry, my interface is a little small here. When we use DynaPurge, we still have cloudiness in our lenses. All right, that would be the polycarbonate. We have found wet regun works, and then I lost your words. Sorry. We have found, this is a good point. When we use DynaPurge, we still have cloudiness in our lenses. These are no doubt, the polycarbonate and the acrylic. We have found wet regun works best. Excellent, excellent observation. It could have been a Alexander Graham Bell moment there. Maybe it was found by accident or solid experimentation. Either way, well said. What is the injection molding world-class acceptable scrap rate? I wish I knew. I know that less is better, not to be trite, but there's I've been in where that can use their regrind, they're not in medical or anything like that, where they're really truly approaching zero over time. That includes startups. The thing about injection molding is when we purge material, that lump's tough to grind and it takes forever to cool, so that usually gets not reused. But other than that, they're effectively darn close to zero. It's possible. It's out there. The other fact is, don't forget, we're barring pricing pressure from our customers. We're in charge of our material costs. In the quoting phase of the program, obviously we're not going to win jobs by, using twice the material as our competition. But there is room there. There is room to account for, it takes more plastic. If we're making, 1 million parts that weigh an ounce each, it doesn't take 1 million ounces of plastic to make them. It takes more than that because we have to account for startup and shutdown waste and things like that. And, customers understand that too. So don't short yourself on materials. Make sure there's enough ordered at the proper price to completely fulfill the job. Can you give any advice for molding lenses and machines that have oversized barrels? Good question. Probably a little specific. This is one I would love to. You see my contact info on the screen there, I think. I'd like to probably take that one offline with you if you want to have a discussion about that. I'm more than happy to help. It gets into more, specific problems that are probably best served, one-on-one. But oversized barrel is a relative term, so perhaps the machine size is not appropriate to the tool. But can't say for sure till I know a little more. But I do appreciate the question. Looks like that might be it for us here, Trey.
Well, perfect, Scott. Thank you so much, and a big thank you for everybody for attending today. Just again, a reminder, we will be posting the slides and the recorded copy online, so do check your email for that in the coming days. Again, a big thank you to everybody at Paulson Training and DynaPurge, our sponsors, for putting on this event today. So again, thanks everybody for attending, and have a great rest of your week.